Hi. Today we're going to go through the PAP paper from 2009, going through question 24. Okay, so question 24 is a wording. It says, freight transport on Titan is mostly by ship, with three types of ship called a pang, a quizzer and a rudel in common use. We're going to denote these by P, Q and R for the remainder of the question. We're told that all three ships are the same shape and design but differ in size. The cargo capacity depends on the hold volume, while the number of crew is proportional to the surface area of the deck. So we know, if we write here on the right hand side, cargo is proportional to volume and crew is proportional to area. Okay, that's going to be useful for me to remember that. Okay, so we're told a quizzer and a rudel taken together have the same length as two pangs. So let's write that out. So a quizzer and a rudel, so that's Q plus R, is equal to the same length as two pangs, 2p. Okay, that's one. Number two, a quizzer and a rudel. A quizzer has a crew that is just sufficient to provide the crew for two pangs and a rudel. Say again, so the crew of a quizzer is just sufficient to provide the crew for two pangs and a rudel. Now we're told in a hint in the question that the shape, for any object of any shape, the surface area is proportional to the square of the object size. Now as all of these ships are the same shape and design, they will have the same constant of proportionality when you're comparing the crew to the area. So we can simply drop the constant of proportionality. So we can simply say that Q squared, so that's the area of the quizzer, is equal to the area of 2 pangs squared, area of 2 pangs plus the area of 1 rudel. The squares, so just to make that much more clear, this is all proportionality, but we're dropping the constant because they're the same shape and design. Okay, so we can put 1 into 2. So we know that from 1, Q is equal to 2p minus R. And therefore we can put that in. So we get 2p minus R all squared is 2p squared plus R squared. And therefore 4p squared minus 4pr plus R squared is 2p squared plus R squared. So we cancel them all off. 2p squared equals to 4pr, or simply p is equal to 2r. Okay, and then from 1 up here, we'll get that q is going to be equal to 2 times 2r minus r, or simply q is equal to 3r. So those are the lengths in terms of lengths of the pang and the quizzer in terms of the length of the rudel. Okay, now we're asked if we're told a fully loaded quizzer wishes to transfer all of its cargo to smaller pangs and rudels while minimizing the number of crew required for this resultant fleet. And we're asked how many pangs and rudels are needed to do this. Okay, so we know that a quizzer has a volume, a cargo hold, equal to some combination of the volume of a pang and a rudel. So as we know, the volume, so the cargo hold is proportional to the volume, and the volume is proportional to the length cubed. We can again drop in the constant of proportionality. We can say that we let Q cubed, the volume of a quizzer, equal to some amount A of pangs plus some amount B of rudels. Okay, so what we can do now is we can use our equations relating P and R and Q and R. And so that will mean we can cancel off our R's and just be left with an equation relating A and B. Okay, so we do that. We replace Q with 3R, so Q cubed is 27R cubed. And then we get P cubed is 8AR cubed plus BR cubed. Therefore, we get 27 equals to 8A plus B. So that's one equation there. Okay, and we were told we want to minimise the number of crew required. I mean, you know the number of crew required is proportional to the surface area. So if you want to minimise the required surface area. So what is the required surface area? Well, that's going to be the number we have, the number of pangs times the area, plus the number of rudels times the area. Which, again, replacing the P with 2R, gives us 4A plus B R squared. So we want to minimise this whilst satisfying this. So what combinations are we allowed to have? So what are our possible numbers? Well, A and B. We can have A being 1, so that gives us 8, so B would have to be 19 to satisfy this equation here. We could have A being 2, and that would be 8 times 2 is 16, so B would have to be 11. A being 3, that would give us 8 times 3, 24, so B would have to be 3. Can we have A being 4? No, that would give us 32, so it's too much. We can't have negative numbers. So these are our only possible solutions. So now we think, well, which ones of these satisfy the minimization of this? Well, 4 times 1 plus 19 is 23. 4 times 2 is 8 plus B is 19, and that's less. And then 4 times 3 is 12 plus 3 is 15. So clearly we see the answer that minimizes it is 3, 3. So the number of pangs is 3 and the number of roodles is also 3. And that's the answer.